In this example, we're using reasoning to determine the validity of a proof. So Bev is claiming that he can prove that 3 equals 4. And Bev starts with A plus B equals C. And that's what's called a premise. And it's we assume that that is true. Now, if we go through, we have 4a minus 3a plus 4b minus 3b equals 4c minus 3c. So each one of those, 4a minus 3a, that equals a. 4b minus 3b is b, and 4c minus 3c is c. So that is true as well. If we go through again, we're combining together our 4 ABs and Cs and our 3 ABs and Cs, and then pulling out the common factors of 3 and 4. Notice that on both sides we have A plus B minus C as a factor on both sides, so we divide both sides by that and we get 4 equals 3. So it looks like everything's fine in there, but there is a problem, and it's a rather simple problem. If we go through the steps now and see where the problem is, we start with A plus B equals C, and that is true. And everything we're doing along the way, we're substituting and rearranging numbers, and that's fine, we can do that. The problem is when we get to the very end and we're dividing. When we're dividing by A plus B minus C, we should recognize that that equals 0. So if you start with A plus B equals C, and you subtract C from both sides, you'll get A plus B minus C equals 0. So what you're doing is dividing by 0. And you're not allowed to divide by 0. So again, dividing both sides of the equation by A plus B minus C is not valid because division by 0 is undefined.